All right, this is example 3B from day 3 notes. Now, if you notice, this is just a regular old function. It's not a position function. It is just a regular function, but we can still find the limit, or what we call the derivative, when we have a change, and this time we're talking about the change in h, but we still want to know what that limit is as x is equal to 3. So the notation for this one is the limit as h goes to 0 of the function, and here is our change, that h. That's what's going to be getting smaller and smaller, and then subtracted by the x plus h minus x. And again, if you notice, the x's in the denominator will cancel out, but we have this function x squared plus 6x minus 10. So we are putting that x plus h every spot we see the variable x. So when we do that, we end up with the limit as it's heading to 0 with the x plus h squared. That was the first spot we saw the x. And then we have the 6 plus the x plus h. The other part of the function was subtracting 10. And then we are subtracting the actual function to get to our limit. So this is where we have subtracting the original function, and that defines how we set up the limit, and then in the denominator the x's go to 0. So when you expand this out, again you guys, if we need help with that part, again, it is doing FOIL. So we get the x squared plus the 2hx plus h squared plus, then we're just distributing that 6. We have our minus 10, and then we are subtracting the function. And again, when you're subtracting that, you are just changing the signs, and it's over our h. So now if you notice, the x squared and the minus x squared goes to 0. The plus 6x and the minus 6x goes to 0. The minus 10 and the plus 10 go to 0. So you are left with this. Now, as I've explained before, if you see that h in every single term, and you can go ahead and simplify that, you may do that process. What I like to do is to actually, you're factoring the h from each term, and you get that h for the factor, 2x plus h plus 6, and it is all over that h in the denominator. And if you see this, that goes to 1. Now, you know a lot of people like to use the word cancel, but when you have h over h, that is actually 1. So you are left with the 2x plus h plus 6. Now we are talking about the h headed to 0. So if I plug that in, that's 0. And what I am left with is the 2x plus 6. Right, so that's that limit of that particular f of x. Now, the last thing it asks is, what is it when x is equal to 3? Plugging that in, and we get 12. This one doesn't actually have any units for that f of x. We're just going to leave the answer 12, and that is the instantaneous rate of change for that function, which is the limit, which is the derivative at x is equal to 3. If you have any questions, be sure and let me know. See you next time.